Welcome to today's explainer. Listen, I am absolutely thrilled about this one because today we are diving deep into a seriously dense, high-yield strategy session on computer science exam mastery. Specifically, we're focusing on a micro lesson around hexadecimal representation retrieval. But really, this document is an alchemist's guide. It is designed specifically to transform IGCSE and O-level students from basic rote memorizers into high-scoring gold standard analytical thinkers. Whether you are sitting for syllabus codes 0417, 0478, 2210, or even AS and A-level 9618, the core challenge is exactly the same. You see it all the time. Think of two classic types of students. We've got Alex. Alex works incredibly hard, studies for hours, and overloads every single answer with raw, unfiltered computer science facts, but includes absolutely zero analysis. And then we have Sam. Sam knows the material too, but Sam rushes, panics, and completely misses the command word requirements in the question. Both walk out of the exam hall feeling pretty confident. Both get their results back and are absolutely crushed by the red pen marks all over their papers. If you've ever felt like you truly know the material but the exam marks just do not reflect your late-night studying, this explainer is going to decode exactly what the Cambridge examiners are actually looking for. We are going to look at the precise frameworks required to completely overhaul how you retrieve and apply your knowledge.
So let's start by addressing a massive and, frankly, incredibly common frustration. Have you ever walked out of a Cambridge computer science past paper? Maybe you were tackling a tricky 417 question, feeling amazing, only to get your paper back and see that your perfectly accurate dictionary-style definition got literally 0 marks? It's infuriating, right? You look at Alex's paper and it's just a massive brain dump of facts. You look at Sam's paper and it's a rushed, incomplete thought. Here is exactly why this happens. Students write the correct short labels, they spit out the facts, but they get absolutely no credit because they lack precise context. The days of simply writing down a memorized definition and collecting your easy points are long, long gone. Cambridge examiners are actively testing your ability to apply concepts to real-world scenarios, not just parrot them back like a robot. They want to see evaluation, justification, and context. Giving them a raw definition is like bringing a dictionary to a poetry contest. You have all the words, but you aren't actually answering the prompt.
So to fix this, we've got a very clear step-by-step structural roadmap for this explainer. First, we'll go beyond rote memorization. Second, we'll introduce the concept compression technique. Third, we'll dive into the rapid method review. Fourth, we're going to break down how to avoid common exam errors. And finally, number 5, we'll look at the 4 exam prompts. Let's get right into it.
Section 1. Beyond rote memorization, moving past isolated facts. This is absolutely crucial, folks. A topic like hexadecimal representation cannot and must not be taught or studied as just a neat little isolated math fact.
Think about the fundamental difference between an isolated fact and a connected concept. If you're Alex, you're living on the left side of this slide. Isolated facts lead to generic responses, just short, standalone labels that leave the examiner thinking, okay, but so what? A connected concept, on the other hand, uses precise terminology, explains the actual processes step by step, and, most importantly, it connects directly back to a specific scenario. To bridge this gap, top students use what we call the PEAL framework. That stands for point, evidence, explanation, and link. You make your point, you provide evidence from your computer science knowledge, you give an explanation of how it works, and you link it right back to the scenario in the prompt. This is how you transform a 0-mark answer into a green checkmark masterpiece. Before we continue, subscribe to our YouTube channel ACETEXAMS at ACETEXAMS_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to the strategy. If the question is about an automated robotics factory, your PEAL paragraph needs to sound like it belongs on the floor of a robotics factory, not in a textbook glossary. That is what Cambridge examiners are scanning for.
There is a core thesis to this entire approach. Terminology becomes meaningful rather than memorized in isolation. When you link a concept to an actual style of analysis or a tangible, real-world digital problem, you move from mere recognition to true understanding. And from understanding, you move to application. That is exactly where the highest marks are hiding in the marking scheme. Terminology is just a tool. It's how you use that tool that gets you the grade.
Moving on to Section 2, the concept compression technique. Answering the why before the what. This is a genuinely brilliant method used within a memory and recall cycle to clarify the real-world purpose of a topic before you even attempt to memorize its technical specifications.
To do this effectively, there are 4 foundational questions you must answer first. Number 1, what digital problem does it solve? Number 2, what data or device is involved? Number 3, what process is taking place? And number 4, what practical consequence follows for a user, a system, or an organization? By answering these 4 questions, you guarantee that your knowledge is firmly tied to a practical scenario. Suddenly, you aren't just memorizing base 16 math for the sake of it. You're actually understanding how MAC addresses function to route data on a network, or how HTML color codes are rendered on a physical screen to show a specific shade of blue. You are answering the why before the what, which compresses the concept into a highly usable, highly retrievable format in your brain.
Now, this foundational work builds directly into your ability to distinguish nearby concepts. Strong theoretical foundations rely heavily on your ability to tell similar things apart. This is where Sam usually trips up. Rushing through the material means learners frequently confuse exact pairs, memory versus storage, or compiler versus interpreter. They also constantly mix up protocol and service, or validation and verification. If you compress your concepts properly using those 4 questions we just covered, you learn to train your brain not just for a single topic explanation, but for direct comparison. And comparison is often exactly what the command words in those high-mark questions are begging for.
Let's look at Section 3, the Rapid Method Review. This is your disciplined path to full marks. Understanding the theory is honestly only half the battle. Transferring that theory into applied reasoning on an intimidating exam paper requires a strict technical methodology.
We call this the Computer Science Success Blueprint. It's a disciplined path with 4 non-negotiable steps. Step 1, identify the exact requirement of the task. Are the command words asking for causes, effects, advantages, or an evaluation? Decode the command word first. Step 2, classify the relevant data, hardware, or software. Step 3, explain how the process works in a clear logical sequence. Think of this as your speed writing challenge. You need to write a perfect paragraph where another learner could easily follow your exact steps. Step 4, connect the explanation back to the context. Examiners want clear, methodical steps, and skipping even one of these completely breaks the logic of your answer. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @AceTheExams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
I really need to reiterate that 4th step of the blueprint, because context specificity is absolutely key. Your answers absolutely must stay inside the provided context of the prompt. If the exam question mentions a smartphone, industrial robotics, a high-frequency banking system, or an e-commerce website, your explanation must remain strictly anchored to that environment. If a question asks you to evaluate a security incident in a primary school and you start talking generally about malware without ever mentioning the school network, the teachers, or the students' data, you are actively losing marks. You have to anchor your technical knowledge to the specific details provided. That is the only way to prove true mastery.
To practice all of this, you should utilize a 3-pass revision cycle. Think of this as a layered study structure built for both retention and transfer. Pass 1 is where you secure your key definitions and contrasts. Pass 2 is where you rehearse worked explanations and draw out the diagrams. But Pass 3 is the ultimate test, and this is where you stop being an Alex. In Pass 3, you change the scenario entirely. You mix similar terms and force yourself to justify your choices aloud. This layered style builds your skills from basic definition recall all the way up to high-level applied reasoning and adaptability.
Which brings us to Section 4, Avoiding Common Exam Errors, Recognizing the Classic Wrong Turns. Diagnosing the exact demand of the question correctly is what prevents you from falling into the trap of just speed writing everything you know about a topic without any real direction.
Let's play a little game of Find the Flaw. When you look at sample paragraphs that lose marks, you'll see specific pitfalls over and over again. Vague wording, confusion between similar terms, missing steps in a process, and the classic failure to answer in context. But pay special attention to the last 2 on this list, giving an advantage with no reason and naming a device without explaining how it actually works. These are incredibly simple mistakes, but they completely sabotage otherwise excellent computer science knowledge. For example, if you know exactly what a router is, but you just drop the word router into your sentence and don't explain its specific role in routing packets across the network in the context of the question, your knowledge goes entirely unrewarded. Examiners cannot give you marks for what they assume you know, they can only mark what is on the page.
Finally, Section 5, the 4 exam prompts, the ultimate exam readiness checklist. So, after you've compressed your concepts and practiced the rapid review, how do you actually know if you are ready for the test?
It all comes down to a crucial 4-prompt checklist. Prompt 1, ask what is it? This targets a clear definition and purpose. Prompt 2, how does it work? This targets a sequential logical process explanation. Prompt 3, where is it used?
This forces you to provide a specific real-world context. And prompt 4, why is it better or worse? This targets a direct comparison to an alternative technology or method. The golden rule here is incredibly simple. If a learner can answer these 4 prompts aloud, right now, without hesitation, their knowledge of hexadecimal representation, or honestly any concept across the 0478 or 2210 syllabus, is completely exam-ready. You are ready to face the paper.
But let's be real, what if you can't answer them? What if you freeze? There is an exact fallback strategy. If you fail the 4-prompt test while studying, you immediately initiate this 3-step recovery process. Step 1, rebuild the topic starting from a key contrast. Remember when we talked about memory versus storage? Start right there. Step 2, review a highly detailed worked example to see the process in action step by step. Step 3, attempt a completely fresh scenario-based question to test your newly applied reasoning. It's a closed-loop system designed specifically to catch your weak spots before the examiner ever gets the chance to see them. And this system works. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
Which brings us to our final critical thought. I want you to ask yourself honestly right now, is your knowledge merely rote memorized, floating in isolation like Alex's, or is it truly ready for the real world? Passing a Cambridge computer science paper isn't about proving you can memorize a glossary. It's about proving you can think, adapt, and analyze like a real computer scientist in any given scenario. I highly recommend applying this exact framework, including the Peel method, to your very next study session. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Thank you for joining me for this explainer. Keep analyzing, and I'll see you in the next one.